Cloud Composer is a managed airflow service. So before we start looking into Cloud Composer, let us see how Apache Airflow works. Apache Airflow is an open source platform for developing, scheduling, and monitoring batch-oriented work. We know that if you have a batch application, we need to run it. For running it, we can either do it on demand or we can schedule the application. So if you want to schedule an application, we need a scheduler. Mostly for simple applications, we use Linux cron tab or Windows scheduler. The problem here is when we need a complex scheduler. Suppose we have multiple tasks and we have to run it one after the other, putting some conditions like one task has to complete before the other one starts, something like that. In that case, we need to orchestrate the running of the tasks. Airflow is such an application where we can orchestrate complex workflows. Let us see the components of Airflow. The main part of the Airflow is a scheduler. Scheduler handles both triggering the workflow and submitting tasks to the executor. The executor is responsible for running the tasks in the workflow. DAG processor parses the DAG file and populates them into a metadata database. This DAG file is a Python file, but doesn't mean that we have to know advanced Python or anything. There are few templates you can use that and write DAG files. The DAG file will configure everything like when the job should start, what are the tasks, what activities are to be done in each of the tasks, the order in which tasks to be executed, etc. Web server provides a user interface to inspect, trigger, and debug the behavior of DAGs and tasks. So we can see in the web UI which tasks are completed, which failed, etc. Then there is a folder. This folder is where we drop our DAG files. That means we write the DAG file, put it into a folder, then the DAG processor will read the file and put it into the database. Metadata DB stores DAGs, the state of the task, and other details. Now let us see a simple representation of how Airflow works. The user writes DAG file in Python format and then places the DAG file into an Airflow folder. The DAG processor which polls the folder reads the file, parses the file, and adds it into a metadata DB. The scheduler will read the configuration from the DB, and when the scheduled time reaches, it will trigger the executors. The executors will start running the tasks. Here we can see task 1 is completed first, then task 2 and task 3 can run parallelly. After that, once these two tasks are over, task 4 will start. So this is the high level view of how Airflow works. Now let us see how Cloud Composer works. We have seen that Cloud Composer is a fully managed Airflow service from Google Cloud for workflow orchestration. It automates, schedules, and monitors data pipelines or DAGs across various cloud and on-prem systems. Then the DAGs. Workflows are defined as DAGs, representing the tasks, their dependencies in the sequence. Pipelines are written in Python, offering flexibility to integrate logic, APIs, data transformation, etc. Composers seamlessly integrate with different products like BigQuery, Dataflow, Databrog, etc. Here is the Cloud Composer architecture. We are looking at the version 3 of the Cloud Composer. Here, most of these services will be deployed in the tenant project, which is handled by GCP. From the Airflow architecture, we know that we need certain components like a folder to place the DAG files. Here in GCP, we use cloud storage for that purpose. Cloud SQL as the metadata database. And then all the workflow services are deployed in the Kubernetes engine as pods. Here we can see that all the applications are deployed in the tenant project, and in the customer project we can see our backups, then the Google Cloud console where we can see the DAGs, logs, etc. Now let us see different types of tasks. Operators are predefined tasks to build most part of the DAGs. Senses are special subclasses of operators which are used for waiting for an external event to happen. Some of the examples are waiting for a file in the cloud storage or waiting for some records in a DB, etc. TaskFlow is a custom Python function packaged as a task. The function will be decorated with @task. Instead of a predefined operator, we can create our own task this way. This shows a task flow. First two lines represent the same orchestration. Here task 1 execute first, then task 2 and then task 3. Last one shows that task 1 completes first, then task 2 and task 3 runs parallel, and once these two tasks are over, task 4 will start. First we import DAG, then the operator we need and any other package we need. Then we will write the DAG. For that we use with DAG. Then we have to give a DAG ID, then schedule or schedule interval parameters. In schedule parameter, we can give a cron tab expression for the schedule. Then a start date, that means when the schedule must start. If it is given a week after, then the job will start only on that day. Next is the catch up. We usually keep it false. Catch up means that if the job is supposed to start 5 months back and scheduled for every day, if catch up is true, then from that day onwards, for every day, it will run the job. That means that many runs it will complete before it reaches today. If you have such a scenario where you want to catch up all the runs, then you can put catch up is equal to true. Otherwise, keep catch up to false. Then we will start defining the tasks. Here bash operator is used. We can configure task ID and then the command to execute here. You can use any operator as you need. We can use operators for running the data flow. Now we'll orchestrate the task. You can see that task 1 start, then the task 2, then the task 3. That is the orchestration of tasks. In the next video, we will see how to create a composer in GCP. Thanks for watching.